Hi there, Mr. Holcomb here with another episode of The Math Behind the Modules. This is Lesson 20, Composite Area Problems. So, the first thing I'm looking at here is the word composite. So, I'm going to pause the video, go get you the definition, and I'll drop it down in here so we can take a look at what the word composite means. Okay, so here we go. A composite figure is made up of several simple geometric figures such as triangles, rectangles, squares, circles, semicircles, and so on. To find the area of a composite figure, separate the figure into simpler shapes whose area can be found, then add the areas together. I will add one little thing to this, and the word add, we could also subtract some areas depending on what we're doing, and number one is a perfect example. So let's move on to number one. Find the composite area of the shaded region. Use 3.14 for pi. So when I look at this, I see a circle, and I draw a circle around here. Okay, the best that I can there. I have that circle there. I also have an inner circle. Right here. So we want to find the area in between these two circles. So this is a composite. So if I found the area of the entire circle, I'm also finding the area of this centerpiece, but there isn't any shaded region there. So what I would need to do is take the area of the bigger circle and subtract the area of the smaller circle, and that would equal, okay, so if we took the bigger circle minus the smaller circle, it would equal the area in between, and that's what we're doing, okay? So we're going to take the area of the bigger circle. So when I look at that, here is my radius. So if I have a center here, and this is my radius, and I look at the values, it went from 5 to 8, that's 1, 2, 3 units. My radius equals 3. Then if I focus on the green circle, or the interior, that was in here. That only goes to there. So this radius from there to there goes from 5 to 7, and that is only a distance of 2. So this radius equals 2. So I have two circles. So if I find the area of the bigger circle, subtract the area of the smaller circle, I get the difference of the two, which is this washer shape diagram. So let's write our formula. Area equals pi r squared. And we're going to subtract the area of this triangle, which is pi r squared, and it's going to equal the area of this. So to finish this problem, I'm going to say area equals 3, and it says use 0.3.14 for pi. So r squared, that would be 3 squared, so that would be 3.14. I'm just going to show all of my work, times 3 squared. Well, that area is now going to be 3.14 times 9. So that area is 9 times 4 is 36, carry your 3. 9 times 1 plus 3 is 12, carry the 1. 9 times 3 is 27, and 1 is 28. Don't forget your decimal. So the area of this is 28.26 units squared. We're going to subtract the area of this triangle, which is pi 2 squared minus, now I'm plugging in 3.14 times 2 squared, which is 4, minus 4 times 4 is 16, 4 times 1 is 4, plus 1 is 5, 4 times 3 is 12. So my answer is going to be, and I should write units squared, so 28.26 minus 12.56, line it up evenly, 0, 7, 12, 7, 0.51, 15.7 units squared is the area of this shaded region. Okay, exercise 1. A yard is shown with the shaded section indicating grassy areas, so we have the dead brown grass, and the unshaded section indicating paved areas, so we have this padded paved area, and the area of the space covered with grass in unit squares. It says to find the area of this space covered in grass. So this is all pavement around here, and then we have something going on here that's not grass. Maybe that's where the house is or a building. They want us to find the grassy area, which is the brown. So the area of a rectangle equals length times width. Okay, and in class I said whenever we're doing a problem like this, the first step is draw a diagram and label it, all the givens. Okay, the diagram was given to us, but we have not labeled our distances. Okay, so what is important here? Do we need E, F, G, H? That's the outside region of this, and that is all paved. That doesn't matter to us. We're looking for the area of this brown. So if I just focus on this rectangle right here, I know that this distance from here to here is 1, 2, 3. So I know the length is 3, so I'll put a 3 down here. And the height is 2, so I'll put a 2 over here. Now when I look at this smaller rectangle in here, okay, it's not shaded, so we have to deduct that or subtract it. This distance from here to here, and this distance from here to here. Okay. This is just an approximation. I'm not real, it doesn't really say what this is, but it looks like 1/4. The half would be here, and that would be so I would say that this is a 1/4, so this is a 1/4. So this distance down here is 1/2, and this distance from here to here is a 1/2, and from here to here is a 1/2, so this distance is 1. Okay, so now we've labeled our diagram, so let me start this over. So I have the area of rectangle A, B, C, D, that's this whole thing, okay, and I want to subtract, let me use the right colors, area of rectangle A, B, C, D, and we're going to subtract the area of the green, which is rectangle IJKL. And that is going to equal the area we're looking for, which is the area of the grassy region. Okay? So now that I've written my setup, now I've got to fill in my formula and use my values that I have labeled. So the area of a rectangle equals length times width. Okay, so let me just move that off to the side there. We're going to use that formula. Okay, so the area of this rectangle is L times W minus, this is a rectangle as well, the length times width of the green. And that is going to equal the area of the grassy region. So the length is 3. Now I substitute my givens. My width is 2 minus, the length is 1/2, and the width is 1. And that is going to equal the area of our grassy region. And then 3 times 2 is 6. We're going to subtract 1/2 times 1, which is a 1/2. And that is going to equal our grassy region. And finally, 6 minus 1/2 is 5 1/2 units squared equals the area of the grassy region. Okay, example 2. Okay, so if this is 4 meters and that's our length, and this is 7.5 meters, that's the height of this whole thing. But somewhere along here we have a semicircle. This is also 4 meters. Okay, so if this is going to be a semicircle, this is my diameter. So over here I'm going to write D equals 4. Well, diameter is equivalent to 2 radii. And since diameter is 4, and that's equal to 2 radii, and I divide both sides by 2, then I find my radius to be 2 meters. So if I put a dot here and draw a line up here, this is a radius of length 2, this is a radius of length 2, this is a radius of length 2 meters. So since that distance from here to here is 2 meters, then this distance down here is 7.5 minus that 2. So this side from here to here is 5.5 meters. Okay, because 5.5 plus 2 more is 7.5. So that was a little bit tricky. We had to find the lengths of the rectangle by subtracting the radius. Okay, so that was a little bit tricky there. So now we have diameter 4, radius 2 meters, and we now have a rectangle and a semicircle. So I'm going to find the areas. So now let me color code this. Let's use red here. So I have a semicircle here, and I have a green. Let's use green. Rectangle here. Okay? Alright, so I'm going to take the area of the rectangle plus, say that again, area of the rectangle plus area of the semicircle. I'll just use S for semicircle. Equals the area of the total region. I'll use T for total. So the area of a rectangle is length times width plus area of a semicircle is, area of a circle is pi r squared. But we only have a half a circle, so we're going to divide that by 2. So we have the length times width plus pi r squared divided by 2, a half a circle, is going to equal our area total. The length of the rectangle is 4. So now we're just substituting. 4. My width is 5.5 plus, and it says to use 3.14 for pi. So I'm going to write 3.14 times the radius, which is 2 squared, divided by 2. That is going to equal our total area. 5 times 4 is 20, carry the 2. 5 times 4 is 22. So that area of this rectangle is 22 meters squared. Plus 2 squared is 4, but 4 divided by 2 is 2. Okay, so this is equal to 4. Let me just write it. 3.14. 2 squared is 4 divided by 2, and that is going to equal our area total. So we have 22 meters squared plus, now this 2 will reduce that 4 down to 2, and 2 times 4 is 8. 2 times 1 is 2. 2 times 3 is 6 meters squared. So half this circle is 6.28 meters squared. And that equals our areas of the total region. So now 22 plus 6 is 28.28 meters squared equals the area of the total region. Okay, Exercise 2. Hopefully you've taken time to try this. If not, pause the video, try it, come back, see if you get the right answer. And here we go. Ready? Set. I'm marking that center because that's the center of this semicircle. The semicircle is here. We have a triangle here. This distance here is 4 centimeters. So that distance here is 4 centimeters. So the radius equals 4 centimeters. Since this is a radius and this is a diameter, D equals 2R. So therefore D equals 2 times 4 centimeters. Their diameter is 8 centimeters. Okay, the diameter is also equivalent to the height of our triangle, 8 centimeters. Okay? So we're going to take the area of a triangle plus the area of a semicircle, and it's going to equal the area of our shape that we have here, which is this. So this plus the semicircle equals the total area. So I'm going to say area of the triangle plus area of the semicircle equals the area total. Okay, so the triangle is here. So area of the triangle is 1/2 length times width, or 1/2 base times height, either or, okay, plus area of a semicircle. Well, the area of a circle is pi r squared, and a semicircle is half a circle, so we divide it by 2, and that's going to equal the area total. Okay, I want to be really specific here, and I'll color code everything for you. That's the semicircle in green, so it'll be pi r squared divided by 2. So now we're going to take and substitute in our givens. The length of the triangle is 14 centimeters times the height of the triangle, which is 8 centimeters, plus, use 3.14 for pi, times the radius, which is 4 centimeters squared, divided by 2. Why did I use black? I have no idea. Let me do that again in green. So it's going to be 3.14 times the radius, 4 squared, divided by 2. And that is going to equal area total. So I've substituted everything in. Now I just need to simplify and solve. Okay, I'm going to get rid of this half first. Half of 14 is 7. 7 times 8 is 56 centimeters squared. That's the area of the triangle. Plus 3.14 times 16, 4 squared, divided by 2. Well, that's going to reduce to 8. 16 divided by 2 is 8. And that's going to equal our area total. So now I'm going to move this up here. So I have 56 centimeters squared plus, and now 8 times 4 is 32, carry the 3. 8 times 1 is 8, plus 3 is 11, carry the 1. 8 times 3 is 24, plus 1 is 25. And that is also centimeters squared. I was lazy without having my units here, but I'll put it in now. And that equals the area total. Now I just have to add everything up. We have a decimal on one but not the other, so I can just write this. 5 plus 6 is 11. 5 plus 2 is 7. Plus 1 is 8. So my total area is 81.12 centimeters squared. Okay, here's example 3. It says find the area of the shaded region. All right, this one's a little bit different. I'm going to just draw this up. We have a triangle there. We have a triangle here. And we have a triangle down here. Okay, and then we have a total square all the way around. Okay, let me try that again. Over here, down, over, and up. Okay, so I'm going to move these things around to show you what I'm trying to do. So I'm going to take this whole piece. Let me move it down to the bottom where I have room. Okay. So if I put this here, that's the total area. I don't want the total area. I just want this little triangular piece in the center. So if I take the total area, why won't this let me grab? There we go. Minus this piece here would give me this big piece here still. I still need to subtract this piece now. And finally, this piece. So what I'm actually doing in this problem is taking the area of the whole piece, subtracting all these areas, and that is going to give me this piece here. I can do better than that, I hope. Okay, so the green plus the red plus the blue plus the black is all of the square. So if I subtract each piece, it's going to give me the leftover piece in the center. And the reason we have to do this is because we don't know how to find the lengths of a diagonal yet. Okay, that's going to come later next year or the year after. So right now we need to use what we know to do these problems. So I know that this side is 20 centimeters. So I'm going to mark that over here. Okay. And we know the top is 20 centimeters. So now we know this thing is a square. Because a square has the same side lengths. So all the sides are 20. So I'm going to mark 20 here and 20 here. Okay? Now the biggest confusion in doing these problems is not knowing where to start. So I try to tell my students start by drawing a picture and labeling the diagram. So this is my picture. And I would call this an exploded diagram. So I drew a diagram and I copied it and moved it over. So now this green piece was from up here, so that's the top of my square, so that's 20 centimeters. I don't know the diagonal, but then I should know this side. So if this piece here is 6 and the whole thing is 20, then this piece here is 20 minus 6, or 14 centimeters. So this is 14 cm on this side. Now if I move to the red triangle, that's right here. And I know that this is 8, and then this piece here would be 20 minus 8, because the whole thing is 20. It's equal to the opposite side. 20 minus 8 is 12. So I know that this is 12 centimeters tall. And the bottom is, oh, I'm sorry, that's 12 down there. Let me move that. This 12 goes here. Okay, so now we have this side here, which we already know as well, because this side of the triangle is this side here. The red one came from here, so it's 20. So this is 20 centimeters. And now we're looking at this tiny little blue one, and they gave us the two sides right there. So this is 8 cm, and this is 6 cm. Okay? So, we got everything all labeled up. So now I need to solve this. So let's start with finding the area of this. So the area equals length times width, or actually this is a square, so how about I just do area equals side squared. So the area equals 20 centimeters squared. So the area is 400 centimeters squared. Okay, now find the area of this. So the area of a triangle is 1/2 length times width. So the area is 1/2 20 times 14. So the area is, and the half of a 20 is 10. 10 times 14 is 140 centimeters squared. Okay, see how this all falls into place? Hopefully it doesn't fall apart. Area equals 1/2 length times width. 1/2 the length is 12. The width is 20. Now I should be writing centimeters here, and then you would see that when we multiply we get squared. So area equals 1/2 of 12 is 6. 6 times 20 is 120. Centimeters times centimeters is centimeters squared. So I'll try to do that in this one here. Area equals 1/2 length times width. So area equals 1/2. The length is 8 centimeters. The width is 6 centimeters. So when I take half of 8, it is now 4. So the area is 4 times 6, 24 centimeters times centimeters, centimeters squared. Ooh. Okay, so we now have 400 minus 140 minus 120 minus 24 centimeters squared equals our area. Not total area. Our area of our triangle. This here. So 400 minus 100 is 300 minus 40 is 260. 160, 150, 140, and minus 24 is 120, and minus 4 is 116. So this is 116 centimeters squared. Now that is cool, and that was fun. Yes? No? I hope you find this fun. I do. All right, exercise 3. Find the area of the shaded region. The figure is not drawn to scale. Well, that's pretty cool. It kind of looks like a Star Trek logo in a way. So let's take a look at this. So again, remember what I said. Step 1 is draw a diagram and label it. Well, in this case, the diagrams are given, so we need to label them. So this is 2 centimeters. I know that. This whole thing is 3. This piece is 2, so if I continued over here, that means that this rectangle up here, if this piece is 2 from here to here, so it's 2 from here to here, then this has to be 1 up here, so this is 1 centimeter. Everybody see that? This is 1, because down here is 2. This is 3. So what else can we find? Can we find this piece here? Let's take a look at something else. Okay, so we have a triangle here. It's a right triangle. We have a rectangle 1 by 3. We have a triangle over here, and this is a quadrilateral. Okay, so there's multiple ways we can do this, but if we look at this whole square here, and this whole square here, and subtract the white pieces, is that possible? Okay, so let's take a look at that. Let me erase this here. So I've written, this is 2, that's true. This is 1, that's true. So I see a big triangle here, which is 2. So, okay, I see. So let's find the area of the first square. So the area of the small square is side squared. And the area and the length of the side is 2 meters. So it's going to be 2 meters quantity squared. the area of the little square is 4 meters squared. Then we have a bigger square here. So if we take the area of the bigger square, the area equals side squared, which is 3 centimeters by 3 centimeters. 3 by 3 is 9 centimeters squared. So the whole area of this shape is 4 meters squared plus 9 centimeters. I got my C here. Centimeters. So the area is 13 centimeters squared. That is all of this. Okay, that's that whole area. So if I subtract this white triangle from that area and subtract this triangle from that area, then we're going to get the blue area. Okay. So I have a triangle here. And I'll do that here, the area of that triangle. Area equals 1/2 length times width. So area equals 1/2, 3 plus 2, 5 centimeters, times the height, 2 centimeters. So the area equals 1/2 of 1/2 of 2 cancels. So the area equals 5 centimeters squared. Oh, I see why I wrote that. There's a misprint. This is 3 centimeters. That said 2 meters. That is impossible, by the way. It's a misprint. That's centimeters. All right, so A equals 5 centimeters squared. Did you follow that? 1/2 times 5 times 2. Half of 2 is 1. 1 times 5 is 5. So the area of this red triangle is 5 centimeters squared. Now I'm going to find the area of this triangle. And I'll do that over here. The area of that equals 1/2 length times width, which is 1/2 the length times the width, which is 3 centimeters times 3 centimeters. So the area equals 3 times 3 is 9 halves centimeters squared, or 4 1/2 centimeters squared. Okay. So the whole area is 13 centimeters squared. And if I subtract this red triangle that's not shaded, that was 5 centimeters squared, and subtract this triangle over here, which is 4 1/2 centimeters squared, and I get 13 minus 5 is 8. 8 minus 4 is 4, minus 1/2 is 3 1/2 centimeters squared. And that's equal to the area. Wow, okay, that's the end of lesson 20. Hopefully you had as much fun as I did. That was pretty cool. Go do your problem set.